let's begin. So log, some basic rules or some properties for logarithms. You may recall that for exponentials, okay, so if you're working with exponents, you have kind of various rules or properties. For instance, if you're going to be multiplying and the base is the same, you're going to be adding up the exponents. If you're going to be dividing and the base is the same, then you're going to be subtracting the exponents and so on. Now, because log is the inverse of the exponential, and if you like, you can take a look at the introduction to functions for logs, put up a link up above, but in here I'll just concentrate on kind of part one of the properties. Now, because of that inverse property for log with respect to the exponent, then we might think that some of the rules might also apply to logs. Like there are certain things that maybe are kind of useful to know about the log. And it is true. Okay, so in this particular video, I'm going to show you kind of the first set of properties. Okay, so these ones, these particular four. And we want to be able to find out what these questions marks actually are. And I'll show you, why they are as they are. Now, for logs, okay, and for exponents, we basically can write an exponent just as a log because it's an inverse of the two. And so for instance, what we can do is notice that we are going to be assuming when we have exponents, okay, and especially for functions, you assume that the base b is greater than 0 and it's not equal to 1. So that means it can't be negative, okay? So we won't make that assumption. And if that's the case, then what you find is that you can write the exponent, so b to the x is equal to y, in this particular case, where you're trying to find the actual exponent by using the log of whatever base that you have, okay, of the output y. So this is going to be pretty useful for us to be able to use for our rules. And by the way, so these are equivalent. So you can write an exponent or a log, but they're equal to each other in terms of how you can write these things. So if I scroll down here, I'm going to bring this kind of back for us. Let me take this, okay, cut it from here and bring it up. Now, let's break these down. So first, what I'm going to do is I'm going to take the rule number 1 or the property number 1. I'm going to erase this, call this x. And the reason why I'm calling it x is because I am basically kind of mapping it out to this. So notice I have a log, okay, I have a log of base b, okay, base b, and then my y, so my y here is equal to 1. And now I want to be able to find, what x actually is. But hold on a second, well, I can find out what x exactly is because I can rewrite this in this particular form. So I can rewrite it in this form. So if I rewrite it in this form, then what I will have is, I will have that 1, which is my y, is equal to my base b, and then it's raised to some exponent, okay, that I have right there, okay, which is x, which is what I'm trying to find. But if you look at this, well, if you know that the base is raised to some exponent x and it's always giving you an answer of 1, well, the only time that that happens is if x is actually equal to 0, right? Because if we take any base and we raise it to the exponent of 0, we know that the answer will be 1. So it turns out that for us, when you're going to be dealing with log of any base, and you're going to be taking it of 1, then your answer is always going to be 0. So that's the first rule that we have, and it comes directly from right here. Now I'm going to use the same trick, okay, for the second one. So what if you have a log, okay, of base b, and then of b, what is that equal to? And if you rewrite this, okay, in exactly the same kind of fashion, so what we have is, so this is my y, which is b, I'm just rewriting, to the b, okay, to some exponent x, which we don't know, but hold on a second, Well, if these are supposed to equal, then what's the exponent? These exponents have to match, which means that this exponent has to be 1. And what that tells us is that this is actually equal to 1, which should make sense to you because logs basically find the exponent. Well, if the base is b, okay, of b, then the exponent on that is actually 1. So that's the second property that we have. Now, the third property, so this one right here, okay, you're going to find is like, okay, I can just keep playing the same trick of rewriting logs in terms of exponents, and you're correct. You can. So what you're going to do is you're going to rewrite, so this is b to the exponent k is equal to b to something that we don't know. Well, since the bases are the same, then if you take a look at this, the exponents have to be the same if the left-hand side is equal to the right-hand side. So that means that my exponent x is just going to be equal to k, and that is true. Again, if you take log of any base, and then you have b to the k inside, well, it's just finding the exponent. Well, if you know that the exponent is k, then that's the answer. So that's the other thing that we have. Here's the last one that we have. Now, this one is actually in exponent form. So notice, okay, it's already in exponent form. So really, this kind of looks like this. So what we have is, you know, y is equal to some base b, and our exponent is a log of bk. And if I rewrite this right there, okay, in the actual log form now, so in the log form, so what would this look like? So it's going to look like log, okay, of your base b, now of y, and it's supposed to be equal to, okay, whatever your exponent is. By my exponent is log of bk. This is exactly what my exponent right here is. I am just following, okay, this structure that I have and the equivalence. So, well, if I look at this, I'll be saying that, okay, well, that's nice. What I have then is, okay, I have log of base b of y, log of base b, okay, of k. So what is my y supposed to be equal to? Well, my y has to be equal to k if these two are equivalent. So here y must be equal to k since I have the same log on both sides. And that's exactly true. So what this means is that right here, since y, okay, was equal to this, then this is just equal to k. So your first kind of 4 set of rules that you have, okay, or properties, they're not very hard to derive if you understand, okay, the equivalence between exponentials and logs, and that's what you would have. Those are actually the answers. So log of b of 1 is going to be equal to 0, because that's what the exponent would have to be to get 1 on a base. Log of b of itself, b is going to be equal to 1. Log of b to the k is equal just to k, because it just takes the exponent. And then b raised to the log of b to the k is equal to k. And these become actually pretty useful as you start working with logs later on in mathematics. But early on, probably you might see this in grade 10 or grade 11. It may not make a lot of sense and you're going to be trying to kind of memorize it. And unfortunately, yes, it's kind of like multiplication tables and, you know, the rules for exponents too. You kind of memorize them, and if you use them often enough, they kind of start sticking. So these are the first 4 that I have. And I'm going to create kind of part 2 of these properties, which are a little bit harder. And they are harder definitely to show, but I'll do that. Okay, and once that video is up, I'll put maybe a link up above there to the part 2 of the rest of the properties. So for now, okay, so hopefully you understand these particular properties. You can see where they come from. They come from the equivalence between the exponential itself and the log right here. Thanks for watching. See you in a future video. Bye, everybody.